Hello friends, in today's class we are going to talk about the last bottom-up parser called as LALR Parser. Welcome back here, and now we are ready to introduce the last bottom-up parser, and that is your LALR. Okay, so that parser is a look ahead LR, and LR is having same meaning. So this parser is look ahead LR parser. So you might be guessing, or you might be tired of this LR parsing, and you might be guessing that what is the new thing we need to do in case of LALR to check the grammar is in LALR. So answer of this question is that we don't need to do anything new. Okay, no collection required, no new table construction. Okay, so the beauty of this LALR is that no new collection required to understand, required. We will work with what? We will work with LR1 collection will be used, and no new table. Okay, no new table. So you might be wondering, if this is not the case, then what we need to do? Okay, so what we need to do is we need to perform the minimization. Okay, minimization of LR1 collection. Okay, so now what we are going to do is we are going to minimize that collection. Now, what is the criteria? Okay, in which situation, or what is the criteria? What is the criteria for minimization? So criteria for minimization, in which case we are going to have a merging of the state. Okay, so the two states can be merged with each other. Okay, two states can be merged with each other if they have same LR0 item. Okay, and same number of items. Okay, follow symbol. Okay, so now because I'm using the term LR0, so that should be same. Follow symbol may be different. Okay, follow symbol may be different. Okay, so that is the criteria for the minimization, that they can have LR0 means I'll tell you the meaning, and follow symbol may be different. Okay, so now if you ask me, if a state is consist of A derive small a capital A dot followed by A or B, and if I say A derive A dot A followed by, let's say, A or B, can I merge this two state? Okay, can I merge this one and this one together? The answer is no, we cannot merge. Why? The reason here in this case is these are not same LR0 item. LR0 item means I'm talking explicitly about this part, not the follow part, only this part. So it should be same. Now definitely if I say that S derive A B dot followed by A, and A derive, for example, A B dot followed by B, can I merge these two? The answer is yes, you can merge these two, and the resulting state will be A derive A B dot, I'll write here A or B. So that is the merging effect. Few more example is like this is example number 1, and I can give you more example. Okay, let me just scroll a bit. Okay, so I can give you more examples. Suppose, can I merge A derive A, B derive A, and followed by A followed by B, and can I merge with A derive A followed by C? Can I merge these two? Okay, so there is a dot here, and there's a dot over here. Can I merge these two? The answer is again no, you cannot merge it, because this consists of two items and this consists of only one item. So dot should be exactly in the same position, follow set may be different. Okay, so dot should be in same position, and follow set may be different. Okay, so follow set may be different. So that is the criteria for LALR that we have to proceed for the minimization. This is a theoretical aspect, and I guess it might not be very clear to you that how to perform this minimization. So now we'll go with some practical example and we'll see the minimization. The second thought you might have is there any issue with the minimization? Okay, so right now I'm not explaining anything. Issue with minimization. So that is we need to see. Okay, we'll see, we'll talk about this later. For the time being, we'll first learn how to minimize and how to fulfill that particular criteria. Okay, so that's all for this session. Thank you.